That's three. Hello, everyone. Hi, thank you for joining us today. Um, I'm so glad that you're here. Thank you for subscribing. Thank you for liking. Thank you for sharing. And thank you for the questions that came in. Um, um, if people listened to the previous session and questions came in. And I'm so glad for the question. So thank you so much for the question. I'm going to read the question, or I'm going to give a brief recap of what we did in the previous session. Then I'll go into the question and we go into the topic for today. So in the previous session, we talked about the colon. We talked about the importance of the colon, the role of the colon, and we talked about the occurrence of resident microbiota in the colon. We talked about the impact that this resident microbiota have to our health. And I did mention, and I think I also showed us a diagram of the activities. I mean the impact of the um, EPS. When we talked about EPS, I did show us that diagram about what they do to us, to human body. Let me use that word. So I'm going to show you briefly about that to see, the activities of of the EPS, because the question that was asked. So here is the diagram that shows you the what's EPS, the impact of EPS in our body. I mentioned that EPS, they are responsible for antioxidant activity. They are, they are good anti-cancer. They have good anti-cancer activity. They have anti-biofilm formation, to strengthen and shield the colonial junction, the integrity. They maintain the integrity of the epithelium. They are good for, they impact our immune system, modulating the immune cells, the immune system. They are good antimicrobial activity because they are able to inhibit and eliminate the occurrence of pathogens in our system. And they are very good at cholesterol lowering ability. So I mentioned briefly on what they do, and we're going to be going into all these activities, step by step in the different sessions that we're going to be having in the future. So that's that on the recap that we had in the previous session. So I'm going to read a question that was sent via WhatsApp to me, and the question was asking. Let me just get it out for us right now. Question was asking about the the uh, the the importance of EPS in alcohol consumption. I want to frame the question as she framed it. So yes, she said, "Thank you so much, Dr. Akroma. This is deep scientific knowledge you have shared. Let me join the others to say thank you. God bless you. My people of this good house, good morning. This is free of charge. Teaching is very important. Let us adhere to it." My lecturer, if I may ask, what does alcohol do to our EPS? So this is a question from Dr. Ibiferi Pauling. she's an expert in biology as well. She's and wanted to know more and have my own perspective on this topic because I had talked on EPS in the session. So yes, and the answer, to our question is that alcohol Alcohol, I'll start by saying that the normal level or the recommended level of alcohol by NHS recommends that, 14 units of alcohol should be taken, not more than 14 units should be taken weekly. So, and that is equivalent to approximately 6 pints of 4% beer, 6 medium glasses of 13% wine, and 14 single measures of 40% spirits. Now, my research, I did research, part of my research, my PhD research, was also looking at alcohol. In fact, I supervised a master's student on the impact of alcohol on our colon cells. And that study was a very good study. We observed that even low percent of alcohol uh, causes oxidative stress. So really, I wouldn't say that there is a safe percent of alcohol. No. So alcohol causes oxidative damage. It causes inflammation. It causes, it disrupts the barrier function. It causes cell injury. It damages the cell, particularly the hepatocytes. The hepatocytes are cells of the liver. Um, Alcohol, disrupts lipid metabolism, thus, resulting into lipid accumulation in the system. So it's important for you to know that alcohol is bad for the system. And although there is a safe recommendation by NHS, just know that alcohol causes oxidative damage, oxidative stress. I mean, it causes oxidative stress. It causes inflammation and it disrupts the integrity of the cells. It disrupts the integrity of the cells, hence allowing the leakage of bacteria like lipopolysaccharides, that also results into inflammation. So with the damage to the integrity of the cells, you have, unfriendly bacteria that will now be serves as, uh, uh, source of uh, impairment to the cells. So it's very, very important that we have that understanding. So it was a study or studies have shown the importance of EPS in the presence of alcohol, where alcoholic liver disease was observed, and EPS was introduced into the system of a rat. That it shows an improvement of the cells, improvement, of the health of the cells. It reduced oxidative stress. It reduced inflammation. So inflammatory markers were reduced as a result of the presence of EPS, but not just the presence of EPS. I have to mention, because this improvement, or this the result of EPS inhibiting oxidative stress and inflammation was observed in high level of EPS, not the low level of EPS. So hence, it is not just the presence of EPS, but the amount, the high amount is very important. Hence, the colony of the bacteria that produces EPS is very important. A high level of the presence of the colony that produces EPS is very important. So, and I did mention that it's important for us to keep our intestine, our colon, our body to give our system the right amount of food that create that good environment for this bacteria to occur. So EPS have been shown to improve the gut hepatic axis, and that means that EPS can um, uh, inhibit liver um, alcoholic liver disease, can repair the cells and can, restore health. But however, we have to understand that it is the amount, the high level that does this. So I hope I've been able to answer this question, because the intake of alcohol, the consumption of alcohol has a negative effect on our cells, on our hepatocytes. That's the cells of the liver and our intestine. And it's important that we have adequate amount of EPS in our system, or adequate amount of bacteria or probiotics that produce EPS. Um, thank you for that question. So we will now go on to talk about today's topic, which is, um, uh, following on from the question, actually, because I'll talk on the importance of the colon and the brain. So there is a crosstalk that occurs between the gut and the brain axis, and alcohol affects not just your liver and the intestine, but alcohol also impacts, negatively on the brain. So the colon contains a variety of specialized cells, including absorptive colonocytes, mucus secreting goblet cells, hormone secreting enteroendocrine cells, proliferating stem cells, and supportive enteric glia. These are all organized, within the colonic epithelium and crypts. And unlike the brain in your skull, um, the the brain that is in the colon it doesn't think like that of the brain in our skull. So it doesn't balance your checkbook or compose a love note, and it doesn't, do your thinking for you, so to say. But its main role is controlling your digestion, from swallowing the release of to the release of from swallowing to the release of enzymes that break down foods, to the control of blood flow that helps with nutrient absorption, and elimination of feces through the anus. So the enteric nervous system is not capable of thought as we know it, so to say, but it communicates back and forth with our brain, and with profound results. So it's important for us to have that understanding that our colon, the health of our colon, is important, and it is impacted, uh, on we should pay attention to our colon, so that we have a healthy colon that have a good communication between the brain, the colon and the brain. So the gut brain barrier is very important in colorectal cancer progression. Um, I'm just going to briefly talk about this for us to have an understanding of the importance of the colon, and the brain. So the gut brain axis, GBA, it plays a vital role in the pathophysiology of colorectal cancer. It influences the tumor progression. It impacts on immune responses, um, and also on therapeutic, outcomes as well. So a bidirectional communication between the gut and the brain is mediated through microbial metabolites. Remember, I spoke about the APS. I mentioned it in the last session, and now in the question that was asked, I was able to give us a brief answer to that question, the importance of the EPS. So the gut-brain axis, it's impacted upon by the gut microbiota, uh, and it's the microbial metabolites are very important. They impact on the neurotransmitters, the neural signaling pathways. They shape the tumor's microenvironment and the systemic inflammation. So very important to know that these microbial metabolites, although they might look like, okay, they are produced by some tiny microscopic uh, uh, organisms, but the metabolites are very important, very effective in their duties in maintaining the health of their host. So they are the tenants that never leaves if we maintain the good environment for them. They are the tenants that grow well if we maintain the good environment for them. So the um, the autonomic nervous system regulates gut motility, immune responses, and inflammation, contributing to CRC progression. So the gut microbiomes, uh, production of bioactive molecules such as short chain fatty acids and neurotransmitters modulate our brain activity, promoting tumor metastasis and immune evasion. So this session today is just briefly to let you know that there is a crosstalk that occurs between the guts and the brain. There is a crosstalk, there is a bidirectional communication, which is influenced by microbial metabolites that influence on the neurotransmission. Um, they are very, very important. And, remember that when you want to, or as you are living your lifestyle, not when you want to, but as you are living your lifestyle, have the understanding that you are promoting uh, the health of your gut, because the health of your gut impacts on the health of your brain. It's been shown that the the health of the gut impacts on it disrupts it disrupts the nervous system, that's the central nervous system. So disruptions of the gut brain axis has been implicated in a broad spectrum of diseases, beyond the central nervous system. So it's been implicated in Parkinson disease, that is a neurodegenerative disorder. So the health of the gut impacts on the well-being of the neurons, the neural system, impacts on its disruption in gut brain axis has been implicated in Alzheimer's disease. So altered gut microbiota and barrier dysfunction contributes to neuroinflammation and disease progression. So having the understanding of, the role of what the microbiota does in your or the microbiota do what they do in your system, it means that you will take that conscious effort to take the right step to have a healthy lifestyle. So psychiatric conditions such as depression, anxiety, and autism spectrum disorder have also been, implicated, in disruptions of the gut-brain axis. Um, it uh, it's it's very, very studies have shown that you have implications of disruptions of gut-brain axis in that it has played key roles in systemic diseases such as type 2 diabetes and obesity. It contributes to hypothalamic inflammation and metabolic regulation. So, and in autoimmune diseases like multiple sclerosis and inflammatory bowel disease, um, you know, it shapes immune responses. So um, our immune responses are dependent on our the health of our gut brain axis, communication between the gut brain axis. So ensuring the health of the gut-brain axis is very, very important and necessary. So I won't take much of your time. Do please ensure that you follow us on the YouTube channel, like, subscribe, and share. And I will be talking more on the steps to take to enhance the health of your colon in subsequent sessions. Thank you. Thank you for listening. Thank you for subscribing. Thank you for sharing. And thank you for spending the time to watch, listen. Please send in your questions, and your questions will be addressed in subsequent sessions. Thank you. Bye.